Let's get started. Again, if you haven't checked in to On Campus, please do that. And a word on the stuff on Campus. When there's a question in the prompt, it's very helpful if you are as specific as possible. All right, so that way I can help people right at the start of class, and we can get all those questions out of the way. When you have stuff like just here or I can't get past X smart score, it's not helpful. These questions need to be as specific as you can. Um, Whatever that means to you, it's the more specific the question, the better that this is gonna be. Especially since I can't, like, I'm not right there with you where you can explain to me the question. Uh, so with that, there really are none from that I can see. Most of like the quote unquote questions are, I can't get past a certain score. Okay, so if you do need help with that, I can help you a little later on Teams. But for right now, like there's nothing I can do in front of you that will help. Okay, so today I want to review a little bit about what we did last class, and then from that I want to go to a specific type of sequence called the arithmetic sequence. All right, so I want to back up just a little bit here for a second. So just as a quick reminder of what summation notation actually looks like, uh, this we absolutely have to know. We have to know every part of this notation, and if we do that and understand what it tells us to do, a lot of this stuff will be a lot easier. Okay, so in this chapter, we're working a lot with different types of functions, right? So this 3i, that's a function. And what we're going to be doing is summing that function over a certain domain. Okay, that's what this really means. All right, and what this entire thing says is that we want to sum that function from I is equal to 1 all the way up until I is equal to 5. Okay, so I'm going to pause there for a quick second. Are there any questions over this stuff right here? All right, and from this, we need to be able to distinguish um, different types of series, right? So there are two different types. There's finite and infinite. Finite means that we have some number where our function is we're gonna stop summing it together. Okay, an infinite series means that we never actually stop. We just continually add things on. All right, and then we went over a couple of examples specifically from the homework. And again, if you have questions over this stuff, that video is available. You just got to go back and fast forward to that part. Okay, so the first couple of points is it finite? Is it infinite? And then how many terms does it have? Keep in mind, the number of terms can be different. It's not always going to be from one to some number. It can start at different numbers, and you have to add on or subtract different terms based on that. Okay, and I think probably the hardest part um, in that homework is sometimes being able to find a rule for the actual sum. All right, and I get that that can be tricky, and that will be a lot easier with practice. Um, but it's something that we just got to get into and struggle with just a little bit. All right. So with that, I want to move on to arithmetic sequences. All right, and again, if you don't have a notebook out, This is something that I would definitely write down so you can have it in front of you. So I'll give people a second to kind of start writing, and then I'll start to explain it here in a second. All right. So we're going to focus on a specific type of sequence today. All right. And this is probably the simplest type. It is called arithmetic. So a sequence whose sequential terms, so every term, has a common difference is called arithmetic. All right. So if we have a sequence of numbers, it is arithmetic if there is a specific number that you're adding on every term. And that specific number is called the common difference. So if we subtract sequential terms, so the second term minus the first term, the third term minus the second term, the fourth minus the third, and the nth minus the one before it, all of those numbers will be equal, and that number is called the common difference. So the first thing that we need to be able to do is just distinguish if a sequence is actually arithmetic. And in order to do that, one second. In order to do that, we need to be able to just determine if we're adding a specific number. So I have two sequences here. I have this first one and then the second one. All right. In this first one, you should notice that the difference between each of these two terms is going to be 5. Right? So we are subtracting 5 in each of these cases. So our common difference, D, is equal to 5. And because this is true throughout the entire sequence, it is an arithmetic sequence. And that may not seem super important right off the bat, but if we can distinguish that a sequence is arithmetic, it can give us a whole bunch of different shortcuts for summing that sequence and for the rules of that sequence. In this second sequence, the general rule is to just subtract sequential terms. So if I subtract 4 minus 1, that's just equal to 3. But then if I subtract 9 minus 4, that's 5, right? And because these two things are different, it can't be arithmetic. And it only takes one set of sequential terms to not have a common difference to make it not arithmetic. Okay? So again, the most important part that you can get from this is the common difference, and there has to be one for it to be arithmetic. So I want to pause there for a second. Are there any questions over what you've seen so far? Yeah, it should be -5. It's the common difference. It's whatever this number is down here. All right, so one of the important parts about just determining what kind of sequence it is that if we can do that, we can get a very easy way to get the rule for the nth term. Okay, so the nth term of any arithmetic sequence will be the first term plus the number of the term minus 1 times the common difference. Because what we're really doing here is we're just multiplying the common difference by some number and then adding that on to the first term. Okay, so for any arithmetic sequence, we can find the nth term using this formula. Okay, so for example, I want you to find a formula for the nth term of the arithmetic sequence whose common difference is 3 and whose first term is 2. All right, so if I were to erase all these, we know that the first term is 2, and we know that the common difference is 3. Right? So we're adding 3 continuously to 2. So if we do that, we'd get 5, we'd get 8, 11, 14, and so on. Right? So that by definition is arithmetic. So that is the sequence, but we don't just want to find terms of a sequence. We want to find the rule for the sequence. We want to find the nth term, and we can do that using the equation above. Okay, so if we start that, an will equal the first term, 2, plus n minus 1 times our common difference, which is just 3. And then we can simplify that a little bit. And then we have our rule. Questions about that? All right, so another example, and again, these will get slightly harder every time. Um, in this case, the fourth term of an arithmetic sequence is 20, and the 13th term is 65. And we want to find the nth term and then find the 11th term. So there are two different things that we need to do. We need to find the nth, and then we need to find the 11th. And we can use the properties of an arithmetic sequence in order to find the nth term and the 11th term. Okay, so we know the fourth and the 13th. And we know that to get from 4 to 13, there have to be 9 terms. So we have to add something 9 times in order to get from the 4th term to the 15th term. So if we just take the difference of those two terms, and then divide that by the number of terms that we have to get from A4 to A13, we'll get our common difference. Okay, so are there any questions about what I just did there? Okay, so after we do that, we can find the first term, and then from that we can find the nth and then the 11th. Okay, so because our common difference is 5, right? If we start at A4 and we go down the line, the third term would have to be 15, the second would have to be 10, and the first would have to be 5. Again, because that common difference has to be true. All right, and then from this, we can find the nth term using our formula. And then given that rule, we can find A11. Are there any questions about that? All right, so we just found the rule for the nth term of an arithmetic sequence. Now we need to find the sum of a finite arithmetic sequence. Okay, so what we're going to be doing is we're going to be summing some arithmetic sequence from some number to some other number, and we're just adding those terms together. So all this really is just adding terms of a sequence and then finding whatever that is equal to. Okay, the equation to do that is given right here. All right, so the sum of the first n terms is equal to the number of terms summed over 2 divided by the first term summed plus the last term summed. So this usually requires just a little bit of interpretation. The n here doesn't necessarily mean the upper index. Okay, it means the number of terms we're actually summing. And the n up top, the numerator n, again, that's not necessarily our upper limit. It's the number of terms we're actually summing. Okay, the first term, again, isn't necessarily the first term of the sequence. It's the first term that we're adding. And the last term, again, might not be the last term of the sequence, but it is the last term that we're actually talking about. Okay, so what this says, and what it's really doing, is it's averaging all the values that we're summing together, and then just adding that however many times we're summing it together. Okay, and that might not make sense. That might be a little bit confusing, but I'll show you here in like 2 seconds. Okay, so for example, we want to find the 150th partial sum of the sequence given. Okay, so what this means is that we're going to be summing 150 terms of this sequence. Okay, the first thing that we have to do is we actually have to find a rule for the sequence. Okay, so if we just find the common difference, it'll end up being 11. Okay, so we know D. And then we can use the rule that we just went over in order to find the rule for the sequence. All right, so our first term is 5, and our common difference is 11. And then from this rule, we can find the last term. So we can find the nth term, in this case, 150th. So when we plug in 150, we get -6 plus 11 times 150, and we can find that number. Which, if we do that, we'll get 1644. And then once we have that, we have everything we need in order to plug into our sum. So the 150th partial sum is equal to the number of terms we're summing together divided by 2 times the first term plus the last term. And again, what this is doing is it's averaging all of the terms that we're summing together and then multiplying by the number of terms we're adding. So if we plug that into a calculator, we get 123,675. Okay, so I want to pause there for a second. Are there any questions over anything that I just did? So what we did here, in order to find the 150th partial sum, we had to find a rule for the series, which is what we did starting here. After we found a rule for the series, we found the last term. And then once we did that, we can plug into our equation. Okay, so your homework is W11 on IXL, right? And it will look a lot like this, where you will be given a sum in sigma notation, and we'll have to actually evaluate that. Okay, so a couple things. We have to pay attention to these two numbers because that tells us how many terms we're actually adding together. In this case, it's just 1 to 16. So the number of terms in our equation is just 16. And then we have to make sure to get the first term and the last term. And then all we have to do is plug that into a calculator and get an answer. So the sum of the first 16 terms of the sequence is 496. Now, sometimes this number will be different, and you have to take that into account. So if that were -3, for example, that's really 4 more terms than 16. So we'd be summing together the first 20 terms of the sequence. And A1 wouldn't be this term. It would be A -3 if we were doing that. Okay, so again, just things you have to keep in mind. Right. So questions about that example? Okay, so your homework is W11, and if you would like to, you can get started on that. Um, I do want to go over an example of where this actually shows up in. And we've actually seen it before. Okay, so, and this is a really simple example of it. Say the starting salary for an accountant is $43,800 with a guaranteed increase of $19.50 a year. Okay, we can find how much we're going to be making over the course of 5 years and any other given year using this arithmetic sequence. Okay, so if we want to determine the salary during the 5th year, we'll know what happens because it's an arithmetic sequence, because we're adding 1950 over and over again. Okay, so our rule for this, an, is equal to the first term plus n minus 1 times our common difference, which in this case is 1950. And then from that, we could just plug in 5 and get an answer. So on the 5th year, we'd be making $51,600. And we kind of already answered this middle one by finding the rule. And then say we were budgeting for the first 5 years. So we wanted to see how much we'd make total over those first 5 years. We can do that by using that sum. So the sum of the first 5 years of salary would be the number of times we're summing it together divided by 2 times the first term plus the last term we can plug that into a calculator and just get a number. So over the course of 5 years, we would have this much to work with. All right, so questions about this example? All right, again, your homework is W11. That'll be due next week. I'll leave this open for a minute. I'll start a quick meeting on Teams, and if you have specific questions, you can ask me there. All right, so general questions here, and then specific questions in a little bit. Okay, so I'll close this and I'll start a meeting on Teams. And if you have questions, I will see you there.